Okay, so I've realised that I have more to tell you about dilution factors. So I've got two different things to say. So first part is, let's imagine that you have 500 cells per mil in my example, and we want 20 cells per mil, and we want 2 mils of that. So the kind of question we'll ask you in the lab is, how do you go about making that solution? So the first thing you have to do is work out the dilution factor, and to do that you divide the number of cells you want by the number of cells, the number of cells you've got by the number of cells you want. So that's 500 divided by 20, so that's equal to 25. So I could write it over my little arrow here, that's what I would normally do. So we need to dilute our sample 25 times to get the concentration we want. So our dilution factor is 25. So that's the first part. And then how do we work out how to make 2 mils of that? So we know that, so 1/25 of the final volume is our original suspension. Okay, because that's our dilution factor. So all we have to do is multiply 2000 microliters times 1/25, which gives us 80 microliters of the cell suspension, and then the rest is water. So that would be 2000 microliters times 24/25. These have to add up to 1. So that would give us 1920 microliters of water, like it would be media in this case. Okay, so we have to work out the dilution factor by diluting the concentration we want by the concentration we've got, and then you need to multiply your final volume by your dilution factor, because the key point here is, I didn't say, is that what this dilution factor means is that 1 part out of every 25 needs to be made up of your original suspension. So we need to work out what volume 1/25 of our volume we want is. Okay, so that's the first thing I wanted to say to you. Second thing I wanted to say to you is about dilution factors that aren't 1 over something. So for example, if we've got 8 microliters of cells plus 2 microliters of iodine. So this is an example from when we were counting algae in the lab. So then the dilution factor is 8/10, because our total volume is 10 microliters, which is 4/5. So then when we get our cell count, we need to multiply that by 5/4. So our original concentration is just a little bit more concentrated, slightly more cells than there are after we've diluted it 4/5. So dilution factors do not have to be 1 over something. And yeah, that works just fine too. So normally you'd multiply your cell count by 100/1, but in this case it's by 5/4. Yeah, so that over 1 has been implied in the things I've been telling you so far, but it doesn't have to be a 1 in your dilution factor fraction. Excuse me.